Let's talk about gain bandwidth product and how it affects your op-amp's performance. So I thought of a goofy example to help illustrate this. Try wiggling your finger as fast as you can and stretch it out as far as you can. So kind of you'll start to see the faster you go, the less you can stretch your finger out. And maybe you can go faster than me, I don't know. But op-amps are kind of similar to that. The farther you stretch it or the more gain you have, then the less speed or bandwidth your op-amp has. And it all comes down to gain bandwidth product. So let's take a look at the MCP 6006 op-amp as an example. Its gain bandwidth product is 1 megahertz. So that means that if your gain is 1, then its bandwidth can be as much as 1 megahertz. But let's say you bump your gain up to, let's say 10, then your bandwidth can only go up to 100 kilohertz. And if we crank up the gain even more to, let's say 100, then your bandwidth can only go up to 10 kilohertz. So no matter the gain, the product of gain and bandwidth is always going to be the same. It's a constant. And for the 6006, it's going to be 1 megahertz. And we can see this in Microchip's Mindi simulator. If we have a simple inverting amplifier, we'll make sure to set the voltage at the non-inverting pin to VDD by 2. And the signal we'll use at the inverting pin for the AC analysis will be offset by 2.5 volts as well. And we'll make sure that both DC and AC are enabled. When we set up the AC analysis, we can have it do a multi-step analysis as well. So we'll sweep a device, we'll call out R1 as the device we're sweeping here, and we'll make it go from 10K to 1 meg, just doing 1 point per decade. Let's add a Bode plot measurement to the simulation and designate V in and V out, then push run. Now you can see that when the gain is 10 or 20 dB, the bandwidth starts declining around 100 kilohertz. When the gain is 100 or 40 dB, the bandwidth declines around 10 kilohertz. And when the gain is 1,000 or 60 dB, the bandwidth declines around 1 kilohertz. Maybe you're thinking, I'm just going to pick an op-amp with a really high gain bandwidth product, then I don't need to worry about this. I'll choose the MCP 6496. It's got a gain bandwidth product of 30 megahertz, and that should cover it. Not so fast. Typically, the higher the gain bandwidth product, the more current the op-amp needs. So the MCP 6496 uses 2 milliamps per amplifier, while the MCP 6006 only needs 50 microamps per amplifier. Also, if your bandwidth is larger, you're amplifying more frequencies, which means you'll typically have more noise as well. So that's about it for gain bandwidth product. If you have any more questions about op-amps, feel free to check out the other videos in this series. Thanks for watching.